Hi, welcome back. In this video, we are going to be talking about hypothesis tests. We're going to be looking at some more information about hypothesis tests and some details. So the first thing I want to do is talk about P's. We've got a lot of different P's in hypothesis tests of proportions, and I think it's a good idea that we get them straightened out. So our first P, the lowercase p, this is the population proportion. This is our parameter. So this is going to be the parameter of our test. Our null hypothesis is going to be based off of this parameter. So it will be that our null hypothesis will be that P is equal to some value P0, but P is the population proportion. P hat, so the lowercase p with the hat, is going to be the sample proportion. This is based off of your data. So this is based off of a sample you have taken. It is data dependent. P-value is going to be a conditional probability, and it is actually the probability of getting your sample statistic or something more extreme if the null is true. And we'll talk about that a little bit more, but this is a conditional probability. It's the probability of getting our data if the null hypothesis is true. And P of A, this is just the probability of event A. So a p-value is a probability, but it refers to a specific probability. P of A is going to be the probability of event A, where A is some event. So now that we have those straightened out, let's talk about our hypotheses. Our null hypothesis is going to be the uninteresting hypothesis. And it's not really necessarily completely uninteresting, but it's not the thing that we are most interested in. The alternative is going to be our claim. In general, we can't prove a null hypothesis right. We can't prove it correct. We are only going to be able to reject it or fail to reject it. That makes the alternative hypothesis much more powerful and interesting. So we want to make the alternative hypothesis the claim. So our null is that nothing has happened or nothing has changed, and the alternative is based on the statement. Now that means if we're just asked if there is a difference, we're not being told that we think the difference is greater than or less than. We will just use not equal to for the alternative hypothesis. If we, before we collect data, have some reason to believe that the improvements we've made to our manufacturing system have reduced the proportion of defects, then we would use a one-tail alternative hypothesis. But we need to come up with this claim and alternative hypothesis before we collect data. We actually need to state the null and the alternative before we have collected data. And that's really important to make sure that we don't have a biased test. So let's look at a couple examples of making hypotheses. So for each of these, we're going to define the parameter and write the null and alternative hypothesis. So for the first question here, observed seatbelt use in 2016 was 92% in states with primary enforcement laws. A state with secondary enforcement laws wants to see if compliance is lower. So the parameter that I am going to be using here is P, and this P value is going to be the proportion of seatbelt compliance in a state with secondary enforcement laws. And just as background, primary enforcement laws mean that if a police officer sees you driving without your seatbelt on, they can pull you over for no reason other than you're not wearing a seatbelt. In secondary enforcement laws, they can't pull you over for not wearing a seatbelt, but if they see you were speeding, they pull you over and you weren't wearing a seatbelt, you can get a ticket. So our null and alternative hypothesis. Looking at this, we want to see if compliance is lower. That means we have reason to believe that the compliance will be lower. That makes this a one-tail test. My null hypothesis is that nothing has changed, that the compliance level is the same. So that is going to be that the compliance in the state with secondary laws is 0.92. And my alternative is that it's less than 0.92, and that has to do with that word lower. Last year, a survey found that 45% of a company's employees were willing to pay for on-site daycare. The company wants to know if that has changed. So I am looking at the proportion of a company's employees who are willing to pay for on-site daycare. We want to be specific and complete in this. We want to make it clear that what our proportion is, and we are looking at we're not looking at, I know what it was last year. I'm interested in understanding if it's the same this year. So I'm going to add the words this year. So my null hypothesis and my alternative hypothesis. My null is that nothing has changed. So that will be that the that the current proportion is 0.45 like it was last year. And I just want to know, has it changed? That doesn't indicate that it will be higher or lower. So that will be not equal. Regular card customers have a default rate of 6.7%. A credit card bank wants to know if that rate is different for its gold card members. So my parameter here will be the default rate. And default rate is the proportion of customers who default on their credit cards. And then default means they just don't pay them. So the default rate for gold card customers at a credit card bank. So now I need to identify my null and alternative. So my null is that gold card customers have the same default rate as regular credit card customers. So that my gold card default rate is the same as my regular credit card default rate. And I just want to know, is it different? That means I am not going to presume it is higher or lower. I'm just going to check to see that it is different. So this will be a two-tailed test. This will be a two-tailed test, and this will be a one-tailed test examining the left tail.